Imagine if our universe is just one tiny speck in a vast cosmic sea, surrounded by countless others, each with its own unique story. It's a mind-boggling idea that challenges everything we thought we knew about the cosmos. Today, we're delving into the groundbreaking work of Sir Roger Penrose, a titan in the world of astrophysics. He flipped the script on our understanding of the universe, proposing a radical theory that suggests there might have been universes before ours, each born from an endless cycle of creation and decay. But how does this mind-bending insight reshape our perception of reality? And could there be an eternal inflation of the multiverse, with universes springing into existence endlessly? Join us on this cosmic journey as we unravel the mysteries of the multiverse and explore the tantalizing possibilities it holds. From the dawn of time to the far reaches of space, we're diving deep into the unknown. Don't forget to hit that subscribe button. Penrose isn't just any scientist, he's a Nobel Prize winner and a knight, honored for his groundbreaking contributions to science. One of his boldest ideas is called conformal cyclic cosmology, or CCC. This theory shakes up our understanding of time and space by suggesting that our universe might have come from a previous one. CC challenges traditional ideas about the universe's beginning and end, pushing us to rethink everything we know. Recently, the James Webb Telescope provided new evidence that supports CCC. These findings clash with our old cosmology, known as Sears 2112. How can this be? Let's dive into the surprises uncovered by the James Webb Telescope and what they mean for Penrose's CCC theory. The James Webb Telescope revealed 16 galaxies that existed even before the Big Bang, along with 6 massive black holes. These discoveries defy our previous explanations. Sears 2112, a galaxy similar to our Milky Way, further challenges our understanding of the Big Bang. It suggests that our old ideas might be missing something crucial. While it took billions of years for our Milky Way to form into its current spiral shape, Sears 2112 existed just 2 billion years after the Big Bang. This timeline suggests that galaxies like Sears 2112 might have started developing even before the Big Bang itself. Sears 21112 has a unique advantage over other galaxies discovered by the James Webb Telescope. It's closer to us, making its light easier to study. This means we can analyze its stars, elements, and formations more accurately. Surprisingly, Sears 21112 shows a level of maturity similar to our Milky Way, but it achieved this billions of years after the Big Bang. Ever wondered what our Milky Way looked like in the early universe? It might have been a tiny, misshapen cluster, or even a fully formed galaxy like it is today, billions of years ago. Sears 21112, with its estimated mass of 3.9 billion solar masses, is larger than expected for its time, but still smaller than the Milky Way. The evolution of galaxies isn't just about size, it's about shape. Galaxies take billions of years to develop their distinctive forms through mergers and growth. How does this fit with Penrose's CCC theory? Well, CCC suggests that the universe didn't start from scratch with the Big Bang, but instead emerged from a previous universe, carrying all the information needed for matter, stars, and galaxies. In Penrose's CCC, each new universe begins with a Big Bang event, but it's not the absolute beginning. Traditional cosmology struggled to explain what came before the Big Bang. Quantum physics proposed a pre-Big Bang state, but couldn't explain its origin. Penrose's CCC fills this gap, suggesting that our universe is part of a larger cycle, with each cycle starting from a previous universe's end. Let's simplify things a bit. Picture a universe much like ours, but with enormous black holes gobbling up all matter. Eventually, when every star and speck of dust had vanished into these behemoths, all physical forces stopped. It's like the universe took a deep breath and paused, a moment we can't even measure in our time scale. Everything was in perfect balance. No forces, no matter. Only the black holes remained, maybe, or they vanished too. Then, from this stillness, a new universe sparked to life, like a burst of energy or a law of cyclical creation. This kick-started the birth of the new universe. One key idea of Penrose's theory is that the universe's end shares similarities with its beginning. He developed the CCC theory by delving into the basics of general relativity and quantum mechanics, two areas often seen as incompatible. Penrose sought to uncover where these disciplines intersected and where they clashed. In his exploration, he focused on singularities and the characteristics of the cosmic microwave background. He discovered that the universe's thermodynamic time direction, governed by the second law of thermodynamics, could offer clues about its large-scale structure. And now you should also realize why the discovery of ultramassive black holes close to the Big Bang supports Penrose's theory. If the information about stars, galaxies, and the formation of matter also flowed directly from an old universe into a new one, it's conceivable that matter and galaxies evolved much faster. If the CCC theory is correct, we would have a completely new starting point. What is time and space, really? It's an exciting thing. The concept of the cyclicity of the universe would also be a coherent subconcept of eternal inflation and the multiverse. Of course, this also raises questions about the nature of time and space in general. The theory of eternal inflation goes back to the work of physicists such as Alan Guth and Andre Linde. The two discovered in the 1980s that after the Big Bang, a tiny region of space underwent a rapid expansion driven by a field called inflation. This inflation smoothed out the original irregularities and created the observable universe. But the theory of eternal inflation goes further and postulates that this process never ends completely. In some regions of space, inflation stops and forms bubble universes, while in other areas it continues, potentially creating an infinite number of such universes. This idea leads us directly to the multiverse and a collection of potentially infinite universes with different physical laws and constants. So what's the big takeaway here? The multiverse isn't just a wild theory, it's a dynamic, ever-expanding realm of possibilities. As we dive deeper into the mysteries of the multiverse, we uncover a universe filled with endless potential and constant evolution. But this journey doesn't end here. Join us as we continue to explore the wonders of space science and unravel the secrets of the multiverse. Hit that subscribe button and stay tuned for more captivating content.